Good day everyone! This video will be about investigating the relation between fluid mechanics and injury, with the goal to minimize injury to the human body due to sudden impact. This is my Term 3 project in Physics 1. So the main idea of this project is for us human beings being prepared to enter the new era after a global virus pandemic, with the helping hands of physics, to transform and reshape the world into becoming a place where all living things and human beings can live normally and in harmony again. So the project focus question for this term is how to transform the new world with the magic touch of physics. And for the big question, it is why is rationality an essential skill for a visionary leader? For the outcomes in this term, it is the sixth outcome, which is fluid mechanics. And it is able to conclude solution of a physical case based on the concept in fluid mechanics. And in this outcome, we focus on daily life phenomena such as eating, showering, or personal hygiene. For the SDGs that is related to the project, there is the third SDG, because my investigation relates to injury. Therefore, people's health and well-being are directly involved in my research and could affect them. There is also the 11th SDG, because with new innovations, we are able to have a more sustainable community, making ourselves more efficient in daily life activities. There were 4 steps in total in my scientific process, including observation, constructing the hypothesis, the Gedanken experiment, and the conclusion. So for my observation, I listed down daily life phenomena that I think cause problems, and my main focus was injury to oneself on accident. The things I listed down were people occasionally dropping and breaking items and hurting themselves, bumping into furniture or any other surfaces, straining furniture on the ground, making them less durable, doors and locks which don't close properly, therefore causing security issues, and electrical mishaps which endanger residents and electronics. From that, we can form a hypothesis. So my hypothesis is people tend to injure themselves seriously when falling by accident more often than realized. And after constructing a hypothesis, we make predictions. If people injure themselves seriously by accident, then when taken care of properly using the right countermeasures, then they should be less injured if it occurs. When seriously injured, you realize that there were also things you could have been more careful of beforehand. After forming a hypothesis, we can do the Gedanken experiment, where I had to do a comprehensive study on an ongoing or past research in physics that is studied or conducted to solve the problems. This part of the scientific methods will be based off my reasoning in conducting my Gedanken experiment. So the issues that I chose to do a comprehensive study on were falling objects, probability of falling and tripping, objects which lose durability upon impact, cause and effects of impacts, the effects of different surfaces and material, and the relation between fluid mechanics and injury. And from that comprehensive study, I chose a main issue which I will focus on, which is how harm is inflicted to ourselves and the environment because of accidents relating to falling, and people tend to drop things or trip themselves on a daily basis, causing injury. So this main issue can be resolved by applying the following concepts of fluid mechanics, which is hydropressure. So what is hydropressure? Since people tend to injure themselves more often than they like, and even though falling seems like a minor thing, if you fall with just the right conditions, the injury may be fatal enough to end your life. This can be seen and explained with the hydropressure concept from fluid mechanics. So, when a person falls from a certain height and lands with their head hitting a hard surface, injury occurs. Because of the harsh impact, the head is affected severely and is currently bleeding. To stop and save the person's life, hydropressure is implemented. So hydropressure is the concept where the pressure that is exerted by a fluid at equilibrium at a given point within the fluid due to the force of gravity. Here is an example. Hydrostatic pressure increases in proportion to depth, measured from the surface because of the increasing weight of fluid exerting downward force from above. As you can see from the diagram, it says that pressure increases with depth. And out of the 3 holes, the strongest jet is from the one that is lowest and furthest away from the surface. Meanwhile, the weakest jet is the one that is closest to the surface, which it would be safe to say that pressure increases with depth. So therefore, the next logical step will be to try and stop the bleeding, which is to exert force on the wound, which then would depend on the depth of the wound, which means the bigger the wound, the higher the pressure you have to exert in order to stop the bleeding. This way, we can see just how fluid mechanics is not only used in fields such as mechanical engineering, but also in the medical field. Here is an example of applying the right amount of pressure with the right material and can stop a bleeding injury. In conclusion, from my research findings on the issue of how falling may cause serious injury, my first hypothesis is proven to be correct. Because from my research, it seems to be easier to take serious damage and not be able to have a full recovery in a short time span, and that when falling, it is vital to take the injury seriously. Through this research, I have learned how important the impact of physics in resolving real-world issues or crises. By applying what I learned in the physics subject, I am able to make suggestions of solutions to solve daily life problems and potentially increase the quality of life. So, to be able to improve the situation, I want to make an item that will be able to minimize small to medium injuries by using the concept of hydropressure from fluid mechanics. And the action that I want to take to publish this research is by presenting it during the Sustainable Innovation Fair to inform others about my findings. This is my item design. So as you can see, it is quite a simple design with weighted cloth, spring, more weighted cloth on the other side, and hand space. So this is the front view and this is the back view of my item. So here's my explanation for it. For the weighted cloth, it is used to provide extra pressure so the wound will be closed in less time and it can be changed out after use. For the spring, it is to help with our push on the wound, and so the recoil after the pressure wouldn't be too bouncy. For the weighted cloth on the other side, it is to provide extra pressure so the wound will be closed in less time, and it can also be changed out after use. And it is also used to cushion the user's hands. For the hand space, it is to give us enough space to use one or both hands to push down and exert pressure on the wound. Next is the hydropressure application. Here, hydropressure can be seen when the tool is applied, where we push down on the wound and the cloth absorbs the blood, and the blood that is trying to exit the wound will be absorbed by the cloth. So both are opposing forces and end up being absorbed by one another. The wound receives the exerted pressure and the cloth receives the blood flowing into it. So, to relate to hydropressure, I have mentioned before in the theory that pressure increases with depth. Therefore, it applies the same way to my tool, and it depends on the wound. So the deeper the wound, then the more the blood would flow out. Therefore, the stronger the pressure we have to apply in order to stop the bleeding. For the user's manual, there are 4 steps in total. First, place the tool on top of the open wound. Second, use one or both hands to push down and exert pressure on the wound. Third, stay for 5 to 10 minutes for minor wounds, and 15 to 45 minutes for medium wounds. And fourth, open the front box and switch out the dirty used cloth for the new one and use the tool again. Lastly, I have some cautions about using this item. First, everybody has different pain tolerances. Therefore, make sure to only apply the right pressure for you for the period of time set. And second, this is not a toy. Children below the age of 12 is advised to consult an adult before use. And lastly, users are recommended to be 16 and above. Thank you for watching!